Hi class, Professor Viersen, and I'd like to talk to you about a few of the problems from the Chapter 8 homework. Chapter 8 has to do with short-term business decisions, and it gives you 6 different business decisions where they give you calculations to give the management an opportunity to choose one alternative from another. Now, this particular problem has to do with product mix when you have a constraint. So let's just jump into this problem. It says each morning, Nate Jepson stocks the drink case at Nate's Beach Hut in Long Beach, California. Nate's Beach Hut has 110 linear feet of refrigerated display space for cold drinks. Each linear foot can hold either 7 12-ounce cans or 7 12-ounce cans or 5 20-ounce plastic or glass bottles. Okay, so I clicked on the data table I have, and so I look down here and it says the first requirement. What is the constraining factor at Nate's Beach Hut? What should Nate stock to maximize profits? What is the maximum contribution margin he can generate from the refrigerated drinks each day? Okay, so I went ahead and I started filling this in, and we know the constraint is he only has 110 linear feet. Okay, so that first of all is his constraint. And when I do this problem, I kind of think of when I walk into a 7-Eleven store. You know, how do they choose what they're going to put out front? Because they only have a certain amount of prime footage where they can sell their products. So then it says Nate should stock the drink with the highest contribution margin. Okay, as we learned from our problems, our previous problems, the contribution margin is the key. So it asks us then to fill in this table, and I went ahead and filled in the contribution margin income statement that says sales price minus the variable cost gives us our contribution margin. And then notice the new part here, because we have a constraint, we have to then include what the constraint is. So how many units per linear foot of the shelf space do we have? And then finally, what is the contribution margin per the constraint, which is the linear foot of shelf space? Okay, just to kind of fill this in, I'll take a minute to do that. Okay, so I went ahead and I filled in this table, and all I really did was just take the information from here and put it over here. So the sales price of each of the different items, the variable cost, which is given here, gave me my contribution margin per unit, and then of course just go back to the original scenario where these are cans, so I can put 7 cans per linear foot, whereas I can only put 5 20-ounce plastic or glass bottles. So the key here then is my contribution margin per linear foot of shelf space. So this is the 12-ounce cola cans are the ones I'm going to focus on. It gives me my highest contribution margin per the constraint. So fill this in, 12-ounce cans. To maximize profits, Nate should devote all of its space to the 12-ounce cans. Okay, so just given that you want to maximize profits and that customers don't care if you only sell one product, you would only put in the cola 12-ounce cans. The maximum contribution margin then for this would be, if I use my calculator to get my information, would be I have 110 linear feet. I'm going to make $8.40 per linear foot, so 8.4. Okay, so I would have a contribution margin of $924. Check my answer. Everything's fine up to this point. Okay, now let's see what else it says. Requirement 2, to provide a variety to the customers, which most companies are going to do. Suppose Nate refuses to devote more than 65 linear feet and no less than 5 feet to any individual product. Under this condition, how many linear feet of each drink should be stocked? How many units of each product will be available? Okay, so first of all, we want to make sure to put in our 65 feet. Our minimum one is 5, so we know we have a total of 40 linear feet left over. The product with the contribution margin, with the highest contribution margin, gets the most feet. The one with the lowest gets the least feet. And of course, the middle contribution, that will get the remaining. Okay, so we have 12-ounce cans. This is going to be the bottles of spring water. It has the lowest contribution margin. And this will be the orange juice. So again, check our answer. So you get the idea. In other words, we want to determine exactly which one of these we're going to use for how much linear feet. Now, the next one says, calculate the units available for sale based on the product mix determined above. So here's our product mix. So how many of the 12-ounce cans are we going to sell? Okay, so we have 65 feet, and we get to have 7 cans per foot. Okay, so first of all, we can have 455 cans. And the number of spring bottles, that will be, obviously, we have 5 feet, and we have a total of 5 bottles per foot, so that would be 25. And finally, we have 40 of the orange juice. Okay, and again, those are 20-ounce containers, so we can have 200 of those. Check our answer. Okay, so now the last part is going to ask us then, under the scenario where we're going to actually use this number of cans and bottles that are available. It says assume the product mix is calculated in requirement 2. So here's our product mix. What contribution margin will be generated from refrigerated drinks each day? Okay, so we go back to this idea of, first of all, we begin with the cola cans. So we have 65 feet. We're going to make our contribution margin of times $8.40, 8.4. And I like using the little arrow to put it in there. And then, of course, our next one is we have 5 linear feet, and this will be times $7.75, so 7.75. And we're going to round off. It says to round off to the nearest whole dollar, so I'm going to go ahead and put that one in. You always have to be careful of the formatting in my accounting lab. I apologize, but it's not perfect, but it's still a good management system. And then the last one will be 40 feet times $8, and that doesn't have any fractions, so we don't have to worry about that part of it. And then adding this all up, we have a total of $905 as our contribution margin using the product mix that we determined in the previous situation. Okay, so that's it for this question. I hope that that was helpful, and I'll talk to you soon.